Example 4, investigating the order of function composition. Suppose f of x gives miles that can be driven in x hours, and g of y gives the gallons of gas used in driving y miles. Which of these expressions is meaningful, f of g of y or g of f of x? Now, the function y equals f of x is a function whose output is the number of miles driven corresponding to the number of hours driven. So the number of miles is equal to f of the number of hours. Now, the function g of y is a function whose output is the number of gallons used corresponding to the number of miles driven. And what this means is the number of gallons is equal to g of the number of miles. The expression g of y takes miles as the input and a number of gallons as the output. The function f of x requires a number of hours as the input. Trying to input a number of gallons does not make sense, so the expression f of g of y is meaningless. The expression f of x takes hours as input and a number of miles driven as the output. The function g of y requires a number of miles as the input. Using f of x, miles driven, as an input value for g of y, where gallons of gas depends on miles driven, does make sense. The expression g of f of x makes sense and will yield the number of gallons of gas used, g, driving a certain number of miles f of x in x hours. Now, are there any situations where f of g of y and g of f of x would both be meaningful for useful expressions? Yes. For many pure mathematical functions, both compositions make sense, even though they usually produce different new functions. In real-world problems, functions whose inputs and outputs have the same units also may give compositions that are meaningful in either order.